And this is a continuation of solving trigonometric equations notes. On example number 6, this is something that most of us would want to do. We would want to divide both sides by cotangent. However, if once we divide both sides by cotangent, we lose some answers. So that's the last thing that we want to. We do not want to divide both sides by cotangent. However, we're going to go ahead and put them on the same side by subtracting 2 cotangent of x from both sides. And let's see what we would get. That gives us cotangent x cosine squared x minus 2 cotangent x equal 0. Now, when you look at both of these terms, it is not going to be quadratics. However, we have common things on both of these terms, which is cotangent. So we'll go ahead and factor that cotangent of x out. When I do, I'm left with cosine squared x minus 2 equal 0. All right. Now, once again, just like example number 4, these are multiplied, so I can go ahead and set both of them equal 0. So on this side, I'm going to do cotangent of x equals 0, and I'm going to let cosine squared of x minus 2 equal 0. Now, we got to think on this one. Where in our unit circle, my cotangent, which is x over y, is going to equal 0, which means my top has to have up in 0, so my x has to be a 0, and that gives us our y-axis, which is pi over 2, and 3 over 2 pi. Now before I close the bracket, I'm going to check on this side to see if we have any more x's that will give us the answer that is going to be equivalent to 0. So cosine squared of x equal 2. Now if I square root both sides, that gives us cosine of x equal plus or minus square root of 2. Now square root of 2 is about 1 point something, which means it's larger than 1. And we talked about in class that our unit circle has a radius of 1, and that's as large as my x or y values will get. So since in this case my x value is larger than 1, we won't have any answers for this one, so we'll just left with that answer. Now let's take a look at example number 7. On example number 7, it kind of looks like what we did before because we have something squared with something and just a number. So this will kind of resemble, or it should look kind of like quadratics. However, if you notice, this sine x squared and cosine x does not match. If the functions do not match, you cannot do the house on this one yet. So we're going to make this into a form where we can factor this with. Now, if you remember our Pythagorean identity, which was sine squared theta plus cosine squared theta equal 1, we can actually solve for sine squared and substitute that in. And do you see how it's going to allow us to have all 1 variables? So let's go ahead and do that here. Okay, so it'll be 2 bracket, my sine squared is 1 minus cosine squared theta, or better yet, x, plus 3 cosine x minus 3 equal 0. And I'm going to distribute those out. So it's 2 minus cosine squared x plus 3 cosine of x minus 3 equals 0, which will simplify to negative cosine squared x plus 3 cosine of x minus 1 equal 0. Oops, that should have been 2. Those should have been 2. Excuse me on that. Now, before I go ahead and do the house method on this, I do not like my leading coefficient being negative. So every time I have it, I go ahead and divide everything by -1 and just get that rid of. If I should really just factor -1 out, but that really does the same thing at the end of the day. Alright. I keep forgetting that too. It's 2 cosine squared x minus 3 cosine x plus 1. Now let's do the house method again. If you want to practice your own house method or do something else to factor, that is also fine. So when you do first times the last, that is +2. And you multiply to get that. The middle number is -3. So we're going to throw a plus sign there because we're going to get a number that's added to it. On the top corner, we'll get 2 cosines and 2 cosine of x. Okay. Now we're looking for 2 numbers that's going to multiply to give us +2 and add to give us -3. That seems like it'll be -1 and -2. And then we're just going to first parenthesis, the first little column becomes a parenthesis of 2 cosine of x minus 1. And this side, it reduces, so this just becomes cosine of x minus 1 equals 0. And this will become cosine of x equal +1/2, because you move 1 to the other side and divide by 2. And this is cosine of x equal 1. Remember, we're setting both of these parentheses equal 0 and solving it out. And I'm skipping some steps, but I know you can follow along. If I'm going too fast, please pause the video and just catch up as you go. Now, this time we're looking for when in my unit circle is my x going to equal 1/2. That means my x has to be positive. Okay, and x is short, which means y is tall. So if y is tall, my x's are going to be over 3. So it'll be pi/3 and 5/3 pi. Also, in my unit circle, my cosine, my x is equal 1 when I'm at 0 or 2 pi. I think the restriction for this one that we put on was that it was going to be 0 less than x less than or equal to 2 pi. So if the 0 was included, you would also include 0 over here.